and you need to participate with those activities. So Jonathan is gonna just make a kind of like arrangement with you, and also Kasu. So Mulgita is gonna just the one who's gonna just contact with either Jonathan or Kasu just to arrange for that. But like for 2 successive weeks, you need to learn SolidWorks, because what I'm seeing is that one of the challenge for the first batch students in working like the project is limitation of knowledge of like software applications. So this week, and I mean the next week, and after that, you're gonna take like SolidWorks. Then you're gonna also arrange auxiliary classes, taking AutoCAD. And for some students, maybe like civil and hydraulics, students, they need also to learn GIS. So we're gonna do that stuff, okay? So ያንን ክላስ አሬንጅ ማድረግ አስፈላጊ ይሆናል ማለት ነው አይደል? እንደዛ ይሆናል ማለት ነው። ስለዚህ እንትን በሉና አሁን ኦልሬዲ በግሩፕ መስራት ጀምራችኋል አሳይመንቱን ወይስ ገና ናችሁ?
ኖ ግሩፕ እንትን አላለም ፕሮፌሰር።
ያ ኦኬ በራሳችሁ ነው በቃ እንትን የምትሉት ማለት ነው። ላይክ ሜቢ አፍተር ዲስ ክላስ ዲስከስ አድርጉና እኔ እዚህ ግሩፕ ውስጥ ነው የምገባው፣ እኔ እዚህ ግሩፕ ውስጥ ነው የምገባው ብላችሁ እንትን አድርጉ። እና አሁን ሜይንሊ ምንድነው ሶፍትዌር ኢንጂነሮች ሶፍትዌር ኢንጂነሪንግ በራሱ ምንድነው ኦክሲለሪ ኢንጂነሪንግ ዘርፍ ነው። ምንድነው ረዳት ነው የሚሆነው አይደል? ለሜካኒካል ኢንጂነሪንግ፣ ለኤሌክትሪካል ኢንጂነሪንግ፣ ለሌሎች ረዳት ነው የሚሆነው። ስለዚህ የሆነ ሲስተም ዴቨሎፕ ቢደረግ ለምሳሌ ኢአርፒ ዴቨሎፕ ቢደረግ ሶፍትዌር ኢንጂነሪንግ ነው የሚሰራው but based upon the request from you guys ማለት ነው። So that's why therefore software engineering group I recommend just to stay in electrical engineering group, but they might just help all the stream from whatever needed whenever we want something. So they're gonna participate in that. So that's what my recommendation. The other is I strongly recommend you just to learn more software applications. The one that I sent you last time with Excel sheet. So you're gonna go and start learning those applications, because recently, most of the things are like automated. So the more you are acquainted in software aspect, then you are going to be benefited. So እዛ ላይ ትኩረት ብታደርጉ ጥሩ ይመስለኛል ማለት ነው። Okay? So yeah, so that's a way. ከዚህ ክላስ በኋላ እንትን ታደርጋላችሁ ማለት ነው። Okay? ትገናኙና አሬንጅ ታደርጋላችሁ ማለት ነው። አሬንጅ ታደርጋላችሁ ከዛ መራርጣችሁ ምናምን ራሳችሁ በዚህኛው በኩል ነው የምንሄደው ትላላችሁ ማለት ነው። otherwise I cannot push ይሄንኛውን እንደዚያ ፑሽ ማድረጉ ብዙ ጥቅም የለውም፣ አስፈላጊ ማለት ነው።
መራርጠን በቃ እንልክልሃለን እንደዛ ይሻላል።
ያ so እዛው ላይ እንትን በሉና እኔ እዚህ ጋር ነኝ፣ እዚህ ጋር ነኝ። ከዛ በኋላ የግሩፕ ሊደር ትመርጣላችሁ አይደል? ከዛ በኋላ
ያ
ሊድ የሚያደርገው so group leader ሲመረጥ based upon experience, based upon like qualification, based upon ability of project management, based upon ability of handling conflicts, time management, all these things are required. Okay, so to be like group leader man. So ያንንም ራሳችሁ ነው የምትመርጡት ማለት ነው ኦኬ ካለው እንትን ተነስታችሁ ተመርጡና ከዛ በዛ መሰረት
maximum limitation አለው ወይ ያሉ ነው chat box ላይ
No, there is no maximum limitation, but like
based on department no.
Yeah, let's say if mechanical group is going to be if it is like 20 students, then we're going to split into two. You get me? Two sometimes. Yeah, two groups. But I don't think it's going to be like maximum limitation.
Data slide, civil, electrical, na mechanical በጣም ብዙ ነው ከ20 ላይ ይበልጣል በተለይ
So I mean that's fine. Yeah. That's fine. That's not bad. So what we're going to do is we're going to just split into two. Like mechanical, if there are like 20 students, then we're going to make like 10, like two groups. Civil also same thing. But like let me know how many students from each. Then we're going to go from that, okay? Okay, so that's great. Okay. Host is not it's disabled now. Just make it.
Okay, let me make you host. All right, sorry. Yeah, you got it.
Okay. Okay. So ለዛሬ መጀመሪያ እንዲሆነ ማሳያችሁ እንትን አለ የሆነ movie, this is just a movie, so I'll show you that movie and unstoppable የሚለው movie. So የሙቪው እንትን ፐርስፔክቲቭ ምንድነው አንድ ባቡር ካለ ሹፌር ያመልጣል ማለት ነው ኦኬ so ምንድነው let me okay this is just communication anyways ምንድነው እዚህ ፉል አንደኛ የእውነተኛ ሙቪ ነው which is just happen in Pennsylvania South Pennsylvania አካባቢ ያጋጠመው ነገር ነው እና ምንድነው it's like መጀመሪያ let me show you here I think this right here so መጀመሪያ and okay I don't know what is that yeah aren't እዚህ ጋር ይሄ የምትመለከቱት ሰውዬ ይሄንን ባቡር እሱ ነው የሚያስነሳው this guy is the one ባቡሩን የሚያስነሳው ማለት ባቡሩን ካስነሳው በኋላ what happened is መንገዱ ላይ የሆነ ታኮ አለ ክሊር ያልተደረገ ነው እና ያንን ባቡሩ እየሄደ ያንን ክሊር አድርጌ እንገባለሁ ብሎ ባቡሩ አውቶማቲክ ስለነበረ ከዛ ራሱን አስነስቶ it's like እዚህ ጋር ነው ጉዳይ ያለው ባቡሩን ሊይዝ ይሞክራል ከዛ አልቻለም ወደቀ ማለት ነው then ባቡሩ escape ያደርጋል ማለት ነው you see አመለጠ ባቡሩ so ያመልጥና የመጨረሻው ምንድነው እዚህ የምታዩት እዚች ጋር የምታዩት እንትን እዚህ በጣም አደገኛ ኬሚካሎች አሉ I think ፕሮፔን መሰለኝ ፕሮፔን የሆነ ተቀጣጣይ ነገር ነው እና ባቡሩ 70 ማይል ፐር አወር ነው ሲበር የነበረው እዛ አካባቢ so እዚህ ከርቭ ላይ ግን እሺ እዚህ ከርቭ ላይ መሄድ ያለበት 15 ማይል ፐር አወር ነው so ያንን ስቶት ከዚህ ጋር ከወደቀ ምንድነው የሚሆነው ማለት ነው ከተማዋ በሙሉ ነው የምትቃጠለው so አሁን ምንድነው እሱ ይሄንን ባቡር ለማስቆም ነው አጠቃላይ just movie ማለት ነው it's like how to stop the train no እንትኑ ማለት ስለዚህ ይሄንን root cause analysis ለመማር ወይ ደግሞ ለምሳሌ 5 whys or fishbone analysis ምናምን ለመማር በጣም ኢምፖርታንት ሙቪ ነው so ሁላችሁም እዩትና just find it somewhere then watch it ከዛ በኋላ ምንድነው የምታደርጉት የመጀመሪያው root cause-ን ሰራላችሁ it's like just choose the root cause እንዴት ባቡሩ escape ሊያደርግ ቻለ how የሚባለው ያ fishbone ሰርታችሁ ከምንድን ነው it's like process human environment machine or you know all these things እንትን በሉ እስቲ brainstorm አድርጉ fishbone then conduct like 5 whys why ትሬኑ ያመለጠበት ምክንያት በምንድን ነው just conduct like 5 whys then እዛው ፊልም ውስጥ containment actions አሉ containment action ያለው ቀደም how to avoid it how to just avoid with a more as like stop how to stop it in damage stop የማድረግ progress ነው አይደለ ያንን የማጥፋት ወይ ደግሞ የማስቆም progress ነው ለcontainment action ምንለው ስለዚህ ምን ስንት አይነት containment actions ተወሰዱ ከነሱ ውስጥ ደግሞ የትኛው successful ነበር you see you're going to just look at it አሁን የመጀመሪያ የሚያደርገው አንድ ባቡር ነጃ ያለ እና ከፊት ለፊት ሆኖ ስፒዱን ነው ሪዲዩስ ለማድረግ ሲሞክር ነበር ኦኬ ከፊት ለፊት ሆኖ ስፒዱን ሪዲዩስ ለማድረግ ቀጥሎም ደግሞ በእንትንም ሊመቱት ነበር ምንድነው ስሙ ሴንሰር አለው የቴምፕሬቸር ሴንሰር እና የቴምፕሬቸር ሴንሰሩ ሃይ ከሆነ ራሱ ስለሚቆም ባቡሩ ስለሚቆም ያችን ሴንሰሯን ሊመቱት ይሞክራሉ ሀዲዱ ላይ ደግሞ ብረት አስቀምጠውም ከበዛ ብረት ሊያቆሙትም ያደረጉት ጥረት አለ ያለ መጨረሻ ላይ እነዚህ ሁለቱ ሰዎች ከመርከቡን ባቡሩን ከኋላ ከፊት ለፊት ሳይሆን ከኋላ መታች አድርገው then try to reduce speedን reduce ለማድረግ ነው የሚሞክሩት ማለት እና እነዚህ ሁላ containment actions ናቸው በዋነኛነት ግን what's going to be the permanent corrective action like እንደዚህ አይነት ነገር happen እንዳያረግ ምን አይነት it's like corrective action መወሰድ አለበት ከዚህ በኋላ እንደዚህ አይነት ነገር እንዳይኖር ማለት so this is very nice movie just to learn root cause analysis እና እነዚህ ያልኳችሁ ነገሮች እስቲ አሁን ከያንኛው ፕሮጀክታችሁ ከመግባቱ በፊት እዚህ ጋርም እስቲ ተነጋገሩና ግሩፕ ከመሰረታችሁ በኋላ እዛ ፊሽቦን ምናምን ምን ይመስላል ምናምን የሚለውን ተነግሩኛላችሁ ማለት ነው ኦኬ ግልጽ ነው እና በደንብ ብዙ ስለሚያስተምር ነው ይሄ root cause analysis በደንብ አድርጎ ያስተምራል። ስለዚህ እኔ በዛ ነው ማስበው ማለት ነው። እና ኦልሬዲ ባለፈው እንትን አይተናል። we already just learn about like AD problem solving last time. AD, we already seen AD model. So what are the 8 steps here? First, D1 is actually before D1 there should be D note. G is problem, and D1 is CRF, cross-functional team, formation of cross-functional team. D2 is D2. This is D2. This is engineering definition. Engineering problem definition, isn't it? Then D3 is containment action. Containment action is temporary corrective action, isn't it? Containment action is a part of like temporary corrective action. Then let me write it in this way, just like that, just like that. CFT, problem solving, statement, then containment action, and D4 is root cause analysis, RCA. Root cause analysis. D5 is what's D5? What's D5?
Corrective action.
Yes, corrective action. D5 is corrective action. Actions, and D6 preventive action. Actually, D6 is validation, isn't it? Validation of the corrective action. And D7?
Preventive action.
Yeah, preventive action. Preventive action. So then the last one is AD. So the last, so here D5, D6, and D7 are called in general, okay? Are called corrective and preventive actions. So this is kappa, isn't it? Kappa. Just like that. Okay, kappa. Then D8 is acknowledgement, isn't it? D8 is acknowledgement of the team acknowledgement or celebration or whatever it is. So this is one of the tools which is applied AD, called as like AD problem solving tool. Okay, we have already just seen what are the different things that are going to just apply for each stage or whatever. So this is just one of approach, okay, in solving like the problem. So the other is we're gonna go and today I'm going to show you the other approach called Six Sigma. Six Sigma. Okay, Six Sigma. Because you're gonna learn some. This also like a part of like problem solving too. So this is just a advancement of total quality management system. Total quality management system. So this method is Six Sigma, is the continuation of like this model, total quality management system. So what is total quality management system? Total quality management system is nothing but, see, I'm going to show you here. So let me show you. So now, previously, it's like how was development. So here, design engineering team. Okay, design is gonna just done by like engineering team. Okay, engineering. Then manufacturing is gonna done by manufacturing engineer. And manufacturer engineer, and other supportive departments like sales, finance, customer service, purchasing. All these guys, they don't know about like what's going on here. So there are like three engineering group here. One is quality, the other is manufacturing, and the other is product or design. Okay, there are like three engineering team. They're gonna just develop the product. Okay, this is development of the product. But this scenario is found inefficient and ineffective, because when we develop the product, then who's going to just sell to the customer? It is the sales department. So these sales needs to know what the product is, to tell about the functionality of the part to the customer. But these sales previously, they don't know about like how the product is developed. So they cannot explicitly and entirely explain the situation or the product service or the product functionality or whatever to the customer. Finance, okay, finance. So now the product is produced, okay, then it's gonna just go to like the customer, and in the customer, there might be like failure. If there is a failure, and this is gonna just turn back to the company. So here, what we have is financial risk. So these guys, because they don't know what the product is, and they don't know how to develop, the product or whatever, they cannot estimate the risk. They cannot estimate it. So who's going to just assist in doing that? It's the engineer. So the engineer also doesn't have a background of like finance. Okay. And customer service is for example, when I send the product to the customer, and if the customer says there is a problem on this part, how I'm going to just fix it? So the customer service department, if they don't know about the product knowledge, how they're going to just tell, the right instruction to the customer? So they might just call from somebody from here. And purchasing, when we develop like the product, okay, when we develop like the product, then we have like suppliers. So those suppliers, in order to characterize them, okay, in order to characterize which supplier is good, which supplier is bad, or whatever, these guys, they might just negotiate like cost, they might just negotiate with material handling, they might just negotiate with transportation or whatever, but they don't know, they may not have like the knowledge of specifications, how to do. So this system is old system. We call it like build wall, okay, build wall system. And now this is changed and grown, okay? So total quality management system, I'll tell you what that means, okay? Okay, so total quality management system. What is total quality management system? It is the involvement of different departments, okay? Okay, this is total quality management system is the involvement of different departments, in product development. So instead of doing things independently, we're gonna think as a system, okay, as a system. That is what total quality management system is. So how it's gonna just work? It's gonna work like this. I'll show you. Okay, it's gonna work like this. So now here is product development. So there is engineering input here, engineering, okay? Then manufacturing input, manufacturing engineering, operations, okay, operations. They have also like input. Sales is a part of that team, sales, and finance, and here you got also purchasing, or any other team that's gonna just relevant, or customer service also, okay? They all are a part of product development, and this is project members or cross-functional team, okay, cross-functional team. So this is called total quality management system. So the next one is, I'll tell you, okay, lean, okay, I'll tell you. Lean engineering. So lean engineering is a part or a method. This is a method to increase efficiency in either engineering or operations. So lean engineering is nothing, but it is the engineering of efficiency. Okay, it's just the engineering of efficiency. So what you are going to just make efficient? Okay, what you are going to make efficient? It could be time. Okay, time. When we say time, there are two types of like time. One is production. Production lead time. Okay, lead time. The second one is delivery lead time. Delivery lead time. So this lead time, production lead time, is the lead time in all the lead time in all value-added processes. Value-added process of, okay, during the production. Value-added, okay, processes during like the lead time in all value-added process. Actually, this process is changed to operation on the product development. So this one is one aspect with respect of like time. So customer needed, when they order, they want to get like on time. So the shortest lead time is more preferable for the customer. So how you are going to just optimize that? And delivery lead time is, this is transportation time. Okay, so in general, lead time is equals to, okay, production lead time plus delivery lead time. So lean engineering is working to minimize this, okay? Lean engineering technique, lean methods are applied in optimizing this production lead time plus what? Plus delivery lead time. So there are techniques. Here an example is spaghetti diagram. This is one method of optimization of like time. This is just to estimate. This is helping to estimate the best lead time in the operations. So when we say operations, it is the realization of process. When we say process, there are like inputs and there are some function, then there is output. So just a mapping. Process is a concept, okay? Just a kind of like concept. or it's a kind of like procedure, or it's a kind of like something that you're gonna do. But like when you say operations, that is realization of, okay, this is realization of, okay, realization of a process. That's what it means, okay? Doesn't matter. Don't forget. That's the difference between process and operations. So that is just, let's say, time, and the other is, let's say, overproduction. This is with respect of like inventory optimization process. Okay, overproduction, inventory optimization methods. More, they are like mathematicals. They are mathematical. They are highly just mathematical. So here there is a method called linear programming, or mathematical optimization method, or whatever. So they are highly just mathematical. So there are a lot of papers that you're going to find. So overproduction is also one of the topic in lean engineering, and the method is inventory optimization. Okay, how you are going to just optimize like your inventory. That's what it is. So when we say like overproduction, that means I'll show you here. So there are sequential operations, okay, like operation 1, operation 2, operation, and so forth like that. Okay, these are like sequential operations. Then you have your warehouse here. Okay, you're gonna put it somewhere like the warehouse. Okay, just by part number or whatever. So then here is just a customer, or when you say customer, it doesn't mean like a person. Just it might be a company. Okay, company. So this is gonna just make order. Then here is like production schedule. So if schedule order greater than if schedule order greater than okay, yeah, greater than customer order, then this is overproduction. That's what overproduction is. So in this scenario, where you are going to just work, you're going to work to optimize here, and to optimize here. Okay, incoming parts. So your optimization is going to be either here, or in process here. Could be right here. Okay, so this is also lean engineering method. So in general, lean engineering, actually you are going to learn what is that about? It is all about efficiency. Okay, it's all about efficiency. So there are like overproduction or whatever. There are also other type of like lean method. So this is the starting point. Okay, this is the starting point. So efficiency. And the other is, I'm gonna go. So agile systems. Systems and methods. So when we say agile, okay, So all the agile system are, okay, agile system are increase effectiveness, okay, effectiveness. This is make it effective, okay, make it effective. So what does effective means? Okay, effective means finish, okay, bring the final output using any resources you have. Okay, so ይሄ ምንድን ነው? አሁን ለምሳሌ አጃይል እና ሊን are they opposite things or አንድ አይነት ነገር ናቸው? ኦፖዚት ቲንግ ናቸው ወይስ ምንድን ናቸው? አጃይል እና ሊን
ያው አውትፑታቸው ወደ ተመሳሳይ ነው የሚሄደው። ፕሮዳክቱ ሞር ሌቭል ለማድረግ የሚሄድ ነው
አይደለም።
እኛው ሪሶርስ ላይ ነው፣ ይሄ ታይም ላይ ነው ፎከስ የሚያደርገው ነው
አይደለም። what is the meaning of effectiveness and what's the meaning of efficiency?
ያው አንዱ ኳንቲፋይ ማድረግ ይቻላል። አንዱ ኳንቲፋይ ማድረግ ይቻላል።
It's about resource utilization.
What is the difference between effectiveness and efficiency?
Efficiency ከሆነ it considers cost ያያል እና definite cost እና definite time መኖር አለበት።
እሺ
አውትፑት እንዳለ ሆኖ ማለት ነው። ኢፌክቲቭነስ ከሆነ ግን ሊቀድምም ሊዘገይም ይችላል። በተሰጠን ጊዜ ኮስትም ከዛ በላይ ወይም ከስበታች ሊጨርስ ይችላል። ግን አውትፑቱ መምጣት አለበት፣ የሚፈልገውን አውትፑት።
Definitely, exactly. Yes. She is correct. Yeah, she is correct. Again? So, yeah, when we say effectiveness and bring the output out. ለምሳሌ ማንቸስተር ሲቲ የሚባል ቡድን አለ አይደል? አሁን እነሱ ምንድነው የሚያደርጉት ማለት ነው? በጣም ብዙ ብር እየከፈሉ ተጫዋቾች ይገዛሉ። አላማቸው ምንድነው? ዋንጫ መውሰድ ነው። ዋንጫ መውሰድ። ስንት ብር አውጥተው? በጣም ብዙ በቢሊዮን የሚቆጠር ብር አውጥተው ዋንጫ መውሰድ ነው የሚፈልጉት። ስለዚህ ምንድናቸው ማለት ነው? እነሱ አጃይል ናቸው። ለምሳሌ ሌስተር ሲቲ ደግሞ የሚባል ቡድን አለ። እሱ ደግሞ ምንድነው? ተጫዋቾች ይገዛል። ምን ይላል? ለምሳሌ 100 ሚሊዮን ሊያወጣ ይችላል ወይ ከዛ በታች ሊያወጣ ይችላል። ግን አላማው ምንድነው? ፕሪሚየር ሊጉ ላይ ሰስቴን አድርጎ መቆየት ወይ በዛም ዋንጫም ሊወስድ ይችላል። So when we say lean ሁሉ ጊዜ minimization of cost, time, እነዚህ የመሳሰሉ ነገሮች ማሳለፍ, just make it like minimal. ይሄንኛው ደግሞ whatever የፈለገ ነገር ይሁን ፋይናሊ ግን የሚፈለገውን ሪዛልት ማምጣት ነው ማለት። that's what agile system is. ስለዚህ የሁለቱ ኮምባይን ስናደርጋቸው ሁለቱ ኮምባይን ስናደርጋቸው agile የሚባል ሲስተም ይሆናል። these are ምንድናቸው ማለት ነው? እነዚህ the most productive ነው። ይሄ ደግሞ okay. Oh, this system, okay, I'll show you here. Agile is the most productive output. Okay, productive. this no, productive. So what does productive means? Productive means both efficient and effective. Okay. So this is agile system natural one. Okay. So there are a lot of methods that you are going to just apply just to make it more everything effective እንዲሆንልን እንፈልጋለን። everything ደግሞ efficient እንዲሆንልን እንፈልጋለን። ግን ዝም ብሎ የሚሆን ነገር አይደለም አይደል? It could not be just happen at a time. ሊሆን አይችልም። ብዙ ሜቶዶች አሉ። So you will learn in the አሁን ወደ በኋላ አካባቢ ትማራላችሁ። Okay? ወደ በኋላ አካባቢ በደንብ ትማራላችሁ። So now we already just seen total quality management system. We already seen agile. We already seen like lean. Okay. Now today's topic is going to be Six Sigma. Okay. Six Sigma methodology. So Six Sigma is nothing, but it's a method. It's a method to achieve. This is a method to achieve efficient and effective. Okay, effective systems via reducing process variance. So the most important concept is, okay, process variance. Variance is the most important concept in Six Sigma methodology. So the topic is, okay, I'll show you here. So let me do some drawing here, okay, and I will show you that stuff. Here you have like normal distribution, and here is like the mean, okay, new. So if you go from this direction, let's say 3 sigma, and if you go this direction again 3 sigma, so this entire region, okay, this region, the region right here is 99.73%. You see, percent are good parts, good parts. Okay, the rest 0.27 parts are bad. That's what it means. If you go to like 3 sigma to each direction, okay, so each direction. So now we're gonna go and add here the same thing. Let's draw. Okay, let's draw normal distribution just like that. So just like this. Okay. So now if you go to 1 sigma, just like this, from these, just 1 sigma, and this is 1 sigma process. 1 sigma process. Okay. If you go to add another sigma here, just like that, and another sigma here, just like this. So this is 2 sigma, this is 2 sigma, and this is called like 2 sigma process. That means like እዚህ ጋር ያሉ ፓርቶች በአጠቃላይ ምንድናቸው ማለት ነው? They are good parts. Okay, so let's go. Yeah, let's go and insert row. Okay, so just like this. So assume this is going to be like that, and this is your mean. So if you are like 6 sigma here and 6 sigma to this direction, 6 times standard deviation, 6 times standard deviation, all these things from here to here, this is called 6 sigma. Okay, I'll show you what does it mean. So let me go now. What does it mean? I'll show you. Conversion of sigma level and BPM. Okay. Image. Yeah. Okay. So let me take this one. BPM. Okay. Yeah. Sigma level. Okay. Just like that. Okay. I think this is good for now. But like, you can expand whatever you like. So as you see here, okay, as you see here, so if it is a 1 sigma process, here, okay, if it is just a 1 sigma process, just like this is 1 sigma, and this is a ppm. That means out of 1 million, okay, out of 1 million, this much are defected, bad. You see, bad. If it is a 1 sigma process, then the ppm is this one. So it's like, in terms of like percentage, only 30.9% are good. Okay, are good. The rest is bad. So this is calculated because this is a probability. 1 minus this probability, the percentage times 10 to the power of 6, a million, is going to give you this result. Okay, this result is going to give you that result. So now, out of 1 million, this much is bad. Okay, and here, out of 1 million, again, this much is bad. When it comes to sigma, like about like 69.1% are good. The rest is bad. So 3 sigma, 93.3, and 4, 99.4, 5, 99.98, and 6, 99.99997. You see, out of 1 million, we only found 3.4 parts bad. That is what 6 sigma is. And the name 6 sigma is come from that. Okay, so let me show you some thing here. Let's say I produce parts with 3 sigma process. Okay, 3 sigma process. Okay, I just produce using like 3 sigma process. This means 0.9973% are good. This is good, isn't it? Good. Bad is body is 1 minus this one, isn't it? Equal to 1 minus this one. And ppm is equal to, okay, bar times 1 million, isn't it? Bar times 1 million. 1, 2, 3, 2, 3, just like that. You see? Out of 1 million, we find this much bad parts, bad parts. Okay? So if your process is 3 sigma, then 99.73% is good, and this much is bad. አሪፍ ነው ነው የምትሉት? አሁን ምንድነው አንዷ ፓራሜትር ነው እንግዲህ ገብቷችኋል? Okay, just let me show you here. Let me show you here. Okay. Crank shaft advanced design. Okay. I will show you what it means. Drawing, advanced drawing. Okay. Let me show you. Now we were discussing things with those. Let's assume you are producing crankshaft, and let's assume, okay, this is just the design. Okay. Let me take some better design and some better correlations. Yeah, I think so. Copy. Then let's do this. Let's do this. Okay. So this is crankshaft. So how many parameters it got? Okay. How many parameters got? You see, distance from here to here, distance from here to here, this radius, you know, radius. Maybe you got some parameters, maybe more than like 40, 50, 60, isn't it? Just more than that. Okay. So let me go here and let me do, if I get some drawing here, drawing, structure design, drawing. እናንተ ጊዜ drawing አይገኙም ማለት ነው። Okay, concentration cheapest design. Okay. Okay. So I'll show you what does it mean, because you're gonna picture of like what it is. So the point is when you do it's like design, then the part, I'll show you here. I think I got it. Yeah. So this is just a part. Now you have a lot of dimensions here. Okay, lot of dimensions. You have, let's say, you see one diameter here, another diameter here, and roughness on the surface, angle on this direction. You see, that's gonna be like 60 degree, and this distance, then that's gonna be given right here. Let me show you more closely. Okay, we're gonna just look at like that. So right here, you see, we're gonna just measure like that angle. That angle is gonna be just given like that. So those are like dimensions. I mean, for the part. And right here, there's like some kind of like circle cutting some radius. And here you have like diameter. So this is just a part, but like it has a lot of dimension, isn't it? Arlaman, lot of quality parameter. And zigar let's say 50 are lower than possible. You see, 50. Assume 50 quality parameters. A part and the part 50 are lower than us. The እያንዳንዷን one, each dimension 1, dimension 2, dimension 3, dimension 4, all እያንዳንዱን በ3 sigma produce ካደረግነው ምንድነው የሚሆነው ማለት ነው? Just like that, isn't it? Yes. አይደለም እንዴ? ልክ እንደዛ ማለት ነው. For each quality parameter ማለት ነው. So if there are 50, then what's gonna be? This gonna be the product, the probability of getting like 2 parts successful. Okay. Let's okay, just like this. Okay, I'll show you. Let's say this is 5. The products. Okay, two quality parameters successful. ሁለት quality parameters successful ሊሆኑ probability ምንድነው የሚሆነው ማለት ነው? The joint probability, isn't it? This one times this one, isn't it? So if there are like 2, this is the probability. So if there are 3, then ሶስተኛውን ስጨምርበት ማለት ነው equal to this one times this, isn't it? That one times this. This is source to show ማለት ነው. አራቱ ሲሆንስ this one is equal to times the 4th one. What about the 5th one? Equal to this one times this, isn't it? Yes. So the probability of getting the part good. So I'm going to show you here. Let me drag it like this, because the formula is defined here. So everywhere is going to just work. So this one, let me drag it down like this. We're going to do like that. So what we learn from this, okay, what we learn. So if the part has like 5 quality parameter, this is a ppm. Okay, out of 1 million, about like 13,000 parts are defective. Now think of 50 quality parameter. 50. One part in it. One part. If it is like 50, then this is equal to power this one times the power of 50. You see? If it is one part, if it has like 50 parameter, and this is the probability of success. So, and the probability of failure is 1 minus, okay, 1 minus this. No, 1 minus this. You see, this is the probability of failure, and the ppm is equal to this one times 1 million. Just like that. You see? If you are in 3 sigma process, and if you have like 50 quality parameter, this is your ppm. This is huge, isn't it? This is very huge. See, almost like 1/8 of the parts are defective, or around like 10%. of the parts are defective. Imagine now imagine an engine. How many parts you got? Maybe 10,000. Okay, 10,000 parts ሊኖር ይችላል። 10,000 parts ሊኖር ይችላል. An engine. So if we are in 3 sigma process, let me show you this, how it looks like. Now, equal to power of 0.9973, then 10,000. You see, 10,000. Okay, 10,000. Like that. 10,000. This is the probability of success. And the probability of failure is 1 minus this number. See? Almost 1. See? Just like that. And ppm is equal to this one times 10 to the power of 6. 1, 2, 3. Just like that. You see? Because it's 10,000 parts. What about like if it's like 8,000 parts? Look at it. 8,000 parts. These much parts are defective. How much is going to be if we are using like 2,000 parts? Then this much parts is defective. So if we are in 3 sigma, then this is how we're going to just calculate. Now, if we're going to just upgrade our production to 6 sigma, this is how the automotive industry works. Okay, I'll show you that. Okay. Okay, 99,99997. Okay. Okay, 9997. This is how many 9? 3 9. 1, 2, 3, 7. Just like that. Put it like that. You see? This is a case. This is a case. Now, if it is like now, this is 6 sigma. This is again like 6 sigma. So if the process is 6 sigma, then if we have, let's say, this one, you see, here color, I'll show you here. Okay, I'll show you there. Then because oh yeah, already just took that stuff. Yeah, the formula is correct. So it's only 149 parts are bad. You see right here, 126,000 parts were bad in 3 sigma. But like in 6 sigma, it becomes just like that. So 6 sigma is able us to reduce process variability. So I'll show you that stuff. Okay, I'll show you the stuff. So now we're gonna go and do like this. Okay, now I'll show you that. So here, insert, now draw. Then we're gonna do here. You see, this is our quality parameter. That's the target. This is the target. This is the target. So now, once target in here, you have like this. Right here, that is your upper specification limit, and this is your let's say just like that, lower specification limit. Okay. Now this is one process. Okay, one process, and the other process is going to be like this, and the other process could be like this, Actually, this bad drawing, very bad drawing. I don't like it. I don't like this. Okay. So the other one is going to be like this. So which process is good now? Which process is good?
The last one.
The last one is good. This
Last
is
one.
good. Yeah, this is good. Yeah.
last
Good.
Narrow one.
Good. And this is relatively bad, isn't it? Bad. So now I'll show you here. When we define Six Sigma, these are like, this one has sigma 1 square, and this one has sigma 2 square, and this is sigma 3 square, just like that. So what we know is sigma 1 square is less than sigma 2 square. Okay, sigma 2 square, and this is less than sigma 3 square, just like that, isn't it? Yes. Yes. So this one is good process, and it's gonna just decrease just to bad one, like that, bad one. Okay, bad one. So those are the things that we need to learn in Six Sigma process. So our objective is, what is our objective now? Objectivation ምንድን ነው? What's our objective now?
To bring the process to Six Sigma. To bring those processes to Six Sigma.
To reduce the process variance.
To reduce process variance. Yeah, reduce process variance. Reduce process variance. Variance no one. You see? ስለዚህ all the methodology in Six Sigma, okay, objective here, okay, I'm sure objective, we already just learned that. So we already just learned that. We already learned this, then we already learned that, and that's just to reduce process variance. Process variance. So what we're going to do is, the method is called DMIC steps. DMIC steps. So the DMIC species, D is define. D stands for define. M stands for measure, and A is for analyze. A is for analyze phase. Then I is improve phase. Then C is the control, phase. Those are the steps in Six Sigma process. Okay, Six Sigma process. So we're gonna just look at what is defined, what is measured, what's analyzed, what's improved, and what's control phase. Okay, we're gonna just look at those things one by one. So are you following me, and are you okay in those things? You are okay in determining those? You are good? Okay. So great. Great. So now, what is defined means? Okay, I'll show you what defined means. Define. So when we say define is all about what's the problem. Okay, what is the problem? And set the scope of the problem. Okay, so when we say what's the problem, we already just discovered there is some problem. The problem is scrap. The problem is functionality. The problem is, customer return or whatever. A lot of things you're gonna learn from the problem. So, and what's gonna be the scope? The scope is a scientific boundary. Okay, a scientific boundary of how to solve up to what level. Okay, up to what level of the problem that we can solve with a pre-specified budget and time. That is what scope means. Okay, that is what scope means. So if you try, there are a lot of problems. So the point is, you cannot solve the problem. Here, you should know you can, or it's better to say you may not solve all the problems at a time. You will solve them step by step and one by one, just like that. This is the core foundation of Six Sigma method. Okay, this one. If you say that you are Superman and you are on the way just to solve every problem at a time, and Six Sigma experts is going to just tell you, you cannot, because you are bounded rationally. Okay, you are bounded rationally. So that's what the scope of the problem is. The scope of the problem. Therefore, which one that we're going to solve? So usually, to determine the scope, okay, to determine the scope, then it is advisory to learn to use like Pareto charts, Power BI, Power BI tools, asking experts, asking operators, experts. This one is experts. Okay, this is no color. Asking operators and any other supportive tool. That's what you're gonna just do. Okay, Pareto chart. You know, for example, for the robot problem, you already just do like the Pareto chart and you understand what is the most severe root cause for the problem. Then you're going to just do, if you try to solve that problem, how much money that you're going to save or whatever. Those things you're going to do. But like in Power BI tools, Power BI is a software, okay? I'll show you. This is by itself is a kind of newly software, emerging software. So Power BI, just a tool. So what is that is gonna just share production data, you know, it's gonna have like production data, then from the production data, then you're gonna just have all the information that you need right there, operator or whatever. So from that, you're gonna tell a lot of information about like the production. So we use Power BI to characterize the definition of the scope. And the other is once the scope is defined, then it is advisory to stick with the current scope and flexibility may be risky. You see, once if you define like the scope, okay, the scope, then the stick ማድረግ ነው ጥሩ እዛው ላይ stick አድርጎ መስራት ነው ጥሩ። It's like if you define it, then እዛ ጋር ተነስተን ነው እንዲህ ብናደርገው ይሻላል እንዲህ it's like አቅጣጫውን መቀየር የስኮፑን አቅጣጫ መቀየር አንዴ እንትን ካለ በኋላ አደገኛ ነው የሚሆነው። ኦኬ በጣም አደገኛ ነው የሚሆነው። ስለዚህ it's like most of the time, I don't have charter here. Most of the time, it's better just to stick with like charter. I'll show you, or I'll send you. Okay. Anyways, so flexibility. Then put your information in the charter. Charter is a matrix that's you're going to just put like information that's going to help in the Six Sigma project. So these are like very smart way of doing like the define phase. And the next one is okay, measure. So when we say measure, people might think this is the data collection step. No, it is not. It's not. Measure contains a lot of things. Measure contains the following. One, review of previous projects. That is one aspect of the measure. One. And the other is to review of the FEMA, control plan, etc. Okay. 2. 3. Sampling method design and taking sample. 4. External and internal data source. It could be his review of scientific literature. All these are okay. All these are in measure phase. Okay. So you're gonna think of these things during like your measure. Okay. Those are like the measure phase. Then the next phase is once you just measure, this is analyze. Analyze is the biggest section in Sigma process. Analyze. Okay, this is analyze. What you're gonna just analyze, this is the biggest. Actually, I can say the essential section in the Six Sigma, process is one of the essential sections. Then the major thing that we are going to just use here are doing design of experiments, quantitative methods. Oh, okay. There is something that I forget here. Here in the measure, you might also do 6 gauge information and gauge studies. 7 PIP-PAPs. PIP-PAP documentation. Okay, PIP-PAP documentation. And any other relevant things. 8. Any other relevant information. So in measure, using all these things, then in the charter, we should put cost information. First is loss. Loss is scrap cost, rework. It could be scrap, rework, and the other is stock out. stock out cost, maintenance cost, customer return, and so forth like that. These are the loss, okay? And gain is, this is equal to the benefits. The benefits if you solve the problem. Okay. Then cost benefit analysis. Okay. Let me do that. Then cost benefit analysis. Analysis and feasibility of the study should be granted here. Okay. Feasibility. What is feasibility? It's the importance whether the project is that really a project or not. Okay. Those are like the thing that you need to know in measure. Okay. In measure. So those things needs to be put in your charter. Okay. Charter is a matrix that you're gonna just develop for your Six Sigma. So first your problem, whatever. So here, like in define, you already have that. Then analyze. Most of the things are like here. The most important thing is use the data that you have collected. Okay, during the measure phase, and then analyze them. Analyze the data set. Okay, so one method of analysis I have already just said, design of experiments, quantitative tools, fishbone analysis also. Fishbone analysis. 5 whys. Okay. Analysis. Then fishbone, or the other is 5 whys. 5 whys. And so forth like that. Okay. These are the method of analysis, and you're gonna have that. So the overall thing that we are going to do is just make any analysis, and output from here is output is okay, root cause of the problem. Okay, what makes the machine showed large variance? What makes this process bad? What makes everything? So that is how you're gonna just discover like the root cause of like the problem. Okay, the problem. Then the next step is improve. The improve phase. So in the improve phase, what you're gonna just improve is, okay, improve is learning what you okay, learning what you have in the analysis phase and then conceptualize it. Nice each. Okay, conceptualize each. Conceptualize each. And conceptualize it. And frame a solution matrix. And implement the solution. Okay. I'm getting very bad writer, isn't it? Just like that. So this phase is the kappa phase. Kappa phase. Okay. See? Generate corrective and preventive actions. Who's gonna just do it? Could be MA. It could be it's like if it is design issue, design problem, then product engineer can do that. Product engineer can do the solution. If it is the gauge problem, then quality engineer can do that, do the solution. If it is production machines and tooling problem, then maintenance or manufacturer engineer can solve that. Maintenance or all these things. It's gonna just generate all these things, then and so forth like that. So now, then the next step is it should be validated. The solution should be validated. How? Using charters, okay? Using charters. Using before and after comparative analysis and follow up. Those are like the tools in the improve phase. Then after that, the next phase is, after the improve phase, that's a control phase. So the control phase is preparation of documentation. You see? In the math now, preparation of documentation. To standardize the method that we found in the control phase, the improve phase. Okay, so these are like the things. So it's a kind of like standardization in your mind. So improve phase here. So what are the control method, work instruction, okay, DFIMA, updated DFIMA, DFIMA, control plan, etc. And implementation of SPC, statistical process control. SPC, statistical control. So these are done in the control phase. Here, in the improve phase, okay, DFIMA review, DFIMA control plan review will be conducted here. Okay, here. So the control phase is only just to make standardize the new method. That's what it is. Make standardize. Minimal no standardize matter. What's the meaning of standardization? What's the meaning of standardization? Atakum standardize matter?
Specification.
level ማድረግ ማለት ነው ፕሮፌሰር
ምን ማለት ነው?
የሜትድ ሶልቭ ያደረግንበት ሜትድ level ማድረግ ማለት ነው። ለምሳሌ ሌላ ኢንቨስቲጌት የሚያደርግ ሰው ካለ ልክ ባለፈው የኮሬክቲቭ አክሽን ያየነው ፕሮሲጀሮች ያሉ እንደዛ አይነት ፎርም ስታንዳርድ የሆነ ማለት ነው።
አይደለም
standardizing mean if the problem happens next time, then we are using this solution method.
No.
Standardizing mean
standardize ማለት ወደ level of ወደ ኮንፎርማንሱ በእንትናችን
ኢምፕሊመንት ለሚያደርገው አካል
ወደ ተለመደውና ወደ የታወቀው መመለስ ማለት ነው።
አይሶ ስታንዳርዳይዜሽን ማድረግ ነው።
ኦኬ ከስተማይዜሽን ማለት ነው። ከስተማይዝድ ዲዛይን ስትሉና ስታንዳርድ ዲዛይን ስትሉ ማለት ነው።
ከስተማይዜሽን ማለት ሪቨርስ ኢንጂነሪንግ
አይደለም።
customized means you can edit.
ባለ ካስተማይዜሽን ስንል ባለ ዲዛይን ወይ ደግሞ ባለ ሜተድ የሆነ ኢምፕሩቭ ካደረክ ያው ካስተማይዝ የምታደርገው ይሆናል ማለት ነው። within the existence design or method ማለት
አይደለም
ካስተማይዜሽን ስንል ያሉ የክሪቲካል ፖይንቶች ሚስ ያደርግ
ኖ አይደለም ኖ that's not no
ከስተማይዝ ስንል በልኩ በምንፈልገው ስንሰራ
ከስተማይዝድ ማለት ኒው ማለት ነው አጠቃላይ ኦኬ ኒው ዲዛይን ማለት ኒው ዲዛይን ኦር ኒው ሜተድ ማለት ከስተማይዜሽን ማለት ስታንዳርዳይዜሽን ደግሞ ማለት ፎርማል ማለት ፎርማል and existing ማለት you see existing okay so standardization is just the way that we know before okay so you're gonna once you make it standardized then everybody's gonna just do it that way but like if it is customized that means new ማለት okay new man additional so control phase line. Okay, control phase line. You are going to make things formal. So this is a way, and this is how you are going to produce. This is how you are going to inspect. This is how you are going to test. This is how you are going to verify. This is how you are going to do, things using like the work instruction or whatever. So they should follow that thing. Okay, they should follow that, and that is called standardization. Okay. So standardization is a tool in lean engineering, isn't it? Yes. Yes, it is. ስለዚህ ስንት ነው ሌክቸር ክላስ ስንት ነው ዛሬ 8 ነው 9 ነው
10
ስለዚህ ነው Okay, so these are the methods that you need to learn in the mic or Six Sigma process model. Six Sigma process. So design for Six Sigma demo mibalala. So new product introduction line. Zilanialo. P-PAP line. Okay. If notes, we're gonna just make it like note or whatever, but like that's in design for Six Sigma. Okay, Six Sigma. Design for Six Sigma is the one that are going to just apply in new product introduction. Okay, let me put here DFSS. This is design for Six Sigma. So this method is Six Sigma, the DMAIC principle, or Six Sigma method. Six Sigma method. የሆነ ድምፅ የሚያስተጋባል እንትን አድርጉት ኦፍ አድርጉት a Six Sigma method that will be applied in a new product introduction, just like that. Okay? Designed for Six Sigma. Right. So I'll show you one example, and we're gonna proceed from that. Okay. So this is the projects that we have been just done. So እዚህ ጋር እንትን አድርጉ መቅረጽ አቁሙ። No recording. Recording should start now.
Okay.